In this video, we'll talk about the concepts behind LVM, how to create logical volumes, display logical volumes, resize logical volumes, how to use LVM snapshots. Let's begin. Logical Volume Management, LVM. LVM breaks up one virtual partition into multiple chunks, each of which can be on different partitions and or disks. There are many advantages to using LVM. In particular, it becomes really easy to change the size of the logical partitions and the file systems to add more storage space, rearrange things, etc. One or more physical volumes, disk partitions, are grouped together into a volume group. Then a volume group is subdivided into logical volumes, which mimic to the system nominal physical disk partitions and can be formatted to contain multiple file systems. There are a variety of command line utilities, tasks to create, delete, resize, etc., physical and logical volumes. For a graphical tool, some Linux distributions use a system config LVM. However, RHEL no longer supports this tool, and there is currently no graphical tool that works reliably with the most recent variations in file system types, etc. Fortunately, the command line utilities are not hard to use and are more flexible anyway. LVM does impact performance. There's a definite additional cost that comes from the overhead of the LVM layer. However, even on non-RAID systems, if you use a strapping, splitting of data to more than one disk, you can achieve some parallelization improvements. Like a RAID, which we'll discuss later, the use of logical volumes as a mechanism for creating file systems which can span more than one physical disk. Logical volumes are created by putting all the devices into a large pool of disk space, the volume group, and then allocating space from the pool to create a logical volume. Logical volumes have features similar to RAID devices. They can actually be built on top of a RAID device. This would give the logical volume the redundancy of a RAID device with the scalability of LVM. LVM has better scalability than RAID. Logical volumes can easily be resized, i.e. enlarged or shrunk, as needs require. If more space is needed, additional devices can be added to the logical volume at any time. Volumes and volume groups. Partitions are converted to physical volumes, and multiple physical volumes are grouped into volume groups. There can be more than one volume groups on the system. Space in a volume group is divided into extents. These are 4 MB in size by default, but the size can easily be changed when being allocated. Logical volumes are allocated from volume groups, can be defined by the size or number of extents. File systems are built on logical volumes, can be named anything, right? So you can take a look at the display on the screen. This is LVM components. There are a number of command line utilities used to create and manipulate volume groups whose name always start with a VG, including VG create. This creates volume groups. VG extend adds to volume groups. VG reduce shrinks volume groups, right? Utilities that manipulate what physical partitions enter or leave volume groups start with a PV and include PV create. This converts a partition to a physical volume. PV display shows the physical volumes being used. PV move moves the data from one physical volume within a volume group to others. This might be required if the disk or partition is being removed from for some reason. It will then be followed by PV remove a partition from a physical volume. You can type man LVM. This will give you a full list of LVM utilities. Logical volume utilities. There are a number of utilities that manipulate logical volumes. Unsurprisingly, they all begin with LV. We'll discuss the most commonly used ones, but a short list can be obtained using this command. Okay, let's take a look at it. It's an OpenSUSE environment. We do ls-of -lv, right? This is the logical volume utilities. These utilities are in SBIN, not in a user SBIN, as they may be needed either for boot or repair and recovery. Right? Most of them are symbolically linked to LVM, a Swiss Army knife program that does all the work, but figures out what is being asked to do based on the name it is invoked with. This is also true for most of the PV asterisk and the VG asterisk utilities, as you can verify easily enough. ls-lf aspen PV. Another one is the VG. Creating logical volumes. LV creator allocates logical volumes from within volume groups. The size can be specified either in bytes or number of extents. Remember, there are 4 MB by default. Names can be anything desired. LV display reports on available logical volumes. File systems are placed in logical volumes and are formatted with the MKFS as usual. Starting with possibly creating a new volume group, the steps involved in setting up using a new logical volumes are create partitions on disk drives type AE in fdisk. And step 2, create a physical volumes from the partitions. 3, create a volume group. 4, allocate logical volumes from the volume group. 5, formatted logical volumes. 6, mounted logical volumes, also update the etc fs tab as needed. For example, assuming you have already created partitions dev sdb1 and dev sdc1 and given them type AE, you do sudo pvc create dev sdb1 and then sudo pv create dev sdc1 and sudo vg create -s16 mac vg dev sdb1. You do sudo vg extend vg dev sdc1 sudo lv create -l50g-n my lvm vg sudo mkfs-t ext4 dev vg my lvm sudo mkdir my lvm sudo monk dev vg my lvm, right? Be sure to add the line dev vg my lvm extend 4 defaults 1 2 to etc fs tab to make this persistent volume. Okay, next. Displaying logical volumes. In order to display information about LVM, there are several command line programs available. PV display shows the physical volumes. If you leave off the physical volume name, it lists all physical volume. PV display dev SDA5, right? VG display shows volume groups. If you leave off the volume group name, it lists all volume groups. VG display dev VG0. LV display shows logical volumes. If you leave off the logical volume name, it lists all logical volumes. LV display dev VG0, LV M1. All right. Resizing logical volumes. One great advantage of using LVM is that it is easy and quick to change the size of a logical volume, especially when compared with trying to do this with a physical partition that already contains a file system. When doing this, extents can be added or subtracted from the logical volume, and they can come from anywhere in the volume group. They need not be from a physically continuous sections of the disk. If the volume contains a file system, expanding or shrinking it is an entirely different operation than changing the size of the volume. When expanding a logical volume with a file system, you must first expand the volume and then expand the file system. When shrinking a logical volume with a file system, you must first shrink the file system and then shrink the volume. This is best done with the LV resize, as in sudo LV resize -r-l 20 GB dev vg my LVM, where the -r option causes resizing of the file system at the same time as the volume size is changed. To grow a logical volume with an ext4 file system, do sudo lv resize -r-l plus 100m dev vg my LVM, where the plus sign indicates adding space. Note that you need not unmount the file system to grow it. You can also reduce a volume group as in sudo pv move dev sdc1, sudo vg reduce vg dev sdc1. The file system cannot be mounted when being shrunk. However, some file systems permit expansion while they are mounted. The utilities which change the file system size are obviously file system dependent. Besides LV resize, we can also use the LV extend, LV reduce, and resize to fs. LVM snapshots. LVM snapshots create an exact copy of an existing logical volume. They are useful for backups, application testing, and deploying VMs, virtual machines. The original state of the snapshot is kept as the block map. Snapshots only use space for storing deltas. When the original logical volume changes, original data blocks are copied to the snapshot. If data is added to a snapshot, it is stored only there. To create a snapshot of the existing logical volume, you do sudo lv create-l 128-s-n mysnap dev vg my LVM. To then make a mount point and mount the snapshot, you do mkdir mysnap mount-o ro dev vg mysnap. To use the snapshot and to remove the snapshot, as sudo umount mysnap sudo lv remove dev vg mysnap. Always be sure to remove the snapshot when you are through with it. If you do not remove the snapshot and it fills up because of the changes, it will be automatically disabled. A snapshot with the size of the original will never overflow. This is the end of this video. Thank you for watching. I'll see you in the next one. Bye for now.